Good evening, pre-calc. This is Ms. Backfish, and I wanted to make you a quick video to help you through some of the stuff you're doing with inverse trig functions tonight. Basically, you're just evaluating inverse trig functions, and all of the ones you're evaluating are unit circle values. So that's actually the easiest situation. When they're not unit circle values, really all you have to do is make a right triangle, but you don't have to worry about that until tomorrow. So first thing I wanted to point out to you, in fifth period, I know I sort of debated this at the board, and we were in a rush, and so I wrote it and moved on. But I wanted to go back to this chart, and I don't know whether I did it right or wrong in third period. Honestly, I can't remember. But in fifth period, I remember having some debate over whether or not inverse cotangent was first and fourth quadrants like tan, inverse tan, and versus 1 and 2. Well, 1 and 2 is correct. Okay, so arc cotan or inverse cotan mean the same thing. When you're doing arc cotan, you look in quadrants 1 and 2. Now for all of these, quadrant 1 is where they would be positive. And so really this quadrant over here is just, if it's negative, this is where you look. You're either looking in quadrant 2 or quadrant 4. We never get a value out of quadrant 3. Okay, so let me go to unit circle. This was another thing that I felt like, let me move that. I felt like we didn't have enough practice time for me to really do a good job of explaining this. So let me just point out something. Remember when we were talking about domains, it was always negative pi over 2 to pi over 2 or 0 to pi in terms of looking at which quadrants it was in. It was never 3 pi over 2. It was negative pi over 2. When we're doing this, if you're using either the first quadrant or the fourth quadrant, basically you're using the fourth quadrant not as if you've gone all the way around, but as if you've gone negative one quadrant. So in other words, if we're using fourth quadrant here, the fourth quadrant values won't be the ones you see here. The fourth quadrant values would be, let me see if I can do this gently, like 11 pi over 6 would actually just be negative pi over 6. And 7 pi over 4, that location would just be negative pi over 4. Same location, but we're referring to it just in terms of a negative rotation. Oh, goodness, that's not good. So 5 pi over 3, we would call that location negative pi over 3. And again, it all goes back to how we refer to the domain. And 3 pi over 2, we're actually referring to in this context as negative pi over 2. So when we're doing this, when we're looking at inverses and when we say something's going to be the fourth quadrant, we're talking about the fourth quadrant as sort of like a reflection of the first quadrant, the negative version of the first quadrant. In terms of, if I'm in the first quadrant, I've rotated positive. If I rotate negative, that's when I go into the fourth quadrant. So these are the values we're using. So you would not give answers like 11 pi over 6. You would say negative pi over 6. Okay, now let's look at some of your homework problems. Oh, I wanted to point this out at the top of your worksheet. This is just a fancy way, well, not a fancy way, but a visual way of saying this. Okay, you notice that sine, tangent, and cosecant are in the first and fourth quadrants. Well, that's what this is saying. Sine, tangent, and cosecant are in the first and fourth quadrants. And cosine, secant, and cotangent are in the first and second quadrants. Let's go back here. That's these two, first and second quadrants, cosine, cotangent, and arc cosine, arc cotangent, and arc secant. Okay, so this is just a visual of saying the exact same thing about which quadrants do I look at. All right, so let's look at some of your homework problems. Very first one, remember that arc means the same thing as inverse. So number 1 and number 2 are saying the exact same thing. Arc sine means the same thing as inverse sine. Okay, so arc sine of 1/2. Well, sine is always either in the first, let's do that, or the fourth quadrant. If it's positive, we look for it in the first quadrant. If it's negative, we look for it in the fourth quadrant. So 1/2 is a positive number. So we're going to go to the first quadrant and look for where sine is 1/2. That's right here, and so my answer would be pi over 6. Okay, next one. Inverse sine of square root of 3 over 2. Square root of 3 over 2 is also a positive number, so also it will be in the first quadrant. So I go to the first quadrant, I look for where the sine is square root of 3 over 2, and that's right here. And no, you can't use your unit circle to do this. You're supposed to know this unit circle well enough to do this. I'm just demonstrating for you on the unit circle so that you know what we're thinking of. Where are we thinking? We're thinking here on the unit circle. And if you need to use it at first, then use it at first, but you need to try and get away from it pretty quickly. So this is where sine is positive square root of 3 over 2. That's at pi over 3. So my answer is going to be for number 2, pi over 3. Number 3, the inverse cosine of 0. Okay, cosine, we look in the first and the second quadrants. Usually we say, well, is it positive or negative? Do we look in the first or the second? Well, it's neither. But there's only going to be one place in the first and the second quadrants that the cosine is 0. And that's right here. So pi over 2 is my answer. Number 4, arc cosine of 1. So inverse cosine of 1. So I'm looking for where, and again, cosine, remember, was in the first and second quadrants. So I'm looking for where in the first and second quadrants the cosine is equal to 1. And that's right here at 0. So 0 is my answer. And this is what I'm doing on all of these. Now, tangent, let's go ahead and talk about this. I'm doing the same thing, but tangent is not something that I see on the unit circle. So it helps to maybe think about what these values are on the unit circle. Remember that tan is the sine over the cosine. Also, remember that tan, we look in first and fourth quadrants. So let's just look at the first and fourth quadrants and see what the values would be of the second coordinate, the sine, over the first coordinate, which is the cosine. So 1 over 0, that would be undefined. Sorry for my writing with the mouse pad. That's a cruddy D, but you get the idea. Okay, this one, at pi over 3, we have this coordinate over this coordinate. Square root of 3 over 2 on top of 1 over 2. We've talked about how when you have the same, when you're dividing fractions and you have the same denominator on both, it pretty much is just going to cancel. So this is like square root of 3 over 1. So square root of 3. Where else would square root of 3 happen? Down here, only it would be what? Negative. So at negative pi over 3, we have negative square root of 3 for our tangent. Notice again that it's a reflection. And same thing here, this is a reflection of 0, 1, so this would be undefined for tangent. So what I'm writing in red here are the tangent values, just to give myself an idea of what they would be. Anytime you put a number over itself, you get 1. So the tangent at pi over 4 is 1. Same thing happens down here, only that number on top of itself, 1 is positive, 1 is negative. So the tangent at negative pi over 4 is negative 1. Now we have pi over 6. Again, you're putting a fraction on top of another fraction. Their denominators are the same, so they'll cancel. So it's 1 over square root of 3. Well, 1 over square root of 3 has to be rationalized. And when we rationalize that, by multiplying the top and the bottom by square root of 3, we get square root of 3 over 3. So that's the tangent of pi over 6. Same thing happens down here, only it's negative. Negative root 3 over 3. And finally, if we put 0 on top of 1, we get 0. So those are the tangent values in the first and fourth quadrants. Okay, and I would, for your benefit, it's better for you to use my commentary on how I got them than to try to just look at this every time or memorize it. It's better to understand that you're just putting the second coordinate over the first coordinate. And really the hardest ones there, the ones you can't really just see at a glance, are this one and this one. Know that if the square root of 3 is on top of the 1, it's just square root of 3. If the 1 is on top of the square root of 3, it gets rationalized into square root of 3 over 3. So let me get rid of my yellow that just kind of got in the way and look at number 5, the arctan of 1. We're looking in the first and fourth quadrants, looking for where tangent is equal to 1. Here it is. Not here because it's not negative 1, it's positive 1, and that's at pi over 4. So my answer for number 5 would be pi over 4. Looking at number 6, arctan or inverse tan of square root of 3. Okay, here it is, positive square root of 3. If it were negative square root of 3, we'd be down here. But positive square root of 3, it's going to be pi over 3. And there we go. Now going on like this, it's pretty much always the same, but we do need to look at the ones that have our reciprocal functions. In other words, the things that are upside down. Like for instance, arcsecant. Well, when you do this, when you say arcsecant of 2, what you're also saying is, and it might be easier to type it, this is the same thing as saying, what's secant go with? Goes with cosine. So arc cosine of, what's the reciprocal of 2? 1 over 2. So arcsecant of 2 is the same as arc cosine of 1 over 2. So I go to 1/2, look for a cosine value of 1/2, and I see a cosine value of 1/2, positive 1/2, right up here at pi over 3. And where are we? There it is. So on the ones that are reciprocal functions, basically translate it to its reciprocal function and flip over the value here. So for instance, on this one, this is like looking for the number 10. It's like looking for the arc cosine of square root of 3 over 2, which is going to be way too much trouble for me to try to type square root of 3. So there we go. Square root of 3 over 2. Number 11 is like looking for the arc sine of 1 over square root of 2, which, remember, we have to rationalize, and that's square root of 2 over 2. Okay, I'm not going to do any more of them for you. Hopefully this gets you a good start. Good luck, and I'll see you tomorrow.